Okay, so I was asked to do a little video on prerequisite number 4, which is really the study of solving inequalities where we don't have simple linear stories, where we're going to have quadratics or cubics or anything that is going to require a little higher end kind of thinking. So let's go ahead and take a look at just a couple of problems that I prepared for this particular video to highlight a couple of ideas. So the first one and the second one are going to be a couple of quadratic inequalities. So we have a couple of different strategies that we can utilize. So I'm going to highlight two different strategies in this first one. So the first thing is we're going to go ahead and try to just see if we can factor it. So what I noticed right away in this problem is that I have 3x times x would be 3x squared. And since 3 is a prime number, literally is not a guess and check. 3x squared is the only thing that can work. Now 20 is a little tougher because when I think about all the numbers that could yield the number 20, I could have 4 and 5, 2 and 10, 1 and 20, a whole lot of different numbers, but I tend to try to start in the middle and then work my way to the sides. And one of the principles for that is that the closer these two values are to each other, the smaller this number is right here. See, if I tried like a 20 here and a 3 here, I'd get a coefficient of like 60 minus a little bit, but it's going to be fairly large. 7 is pretty small. So that means I'm probably going to need two numbers that are relatively close together, okay? So it's either a 4 and a 5 is what I'm thinking. So I got to decide if I want 4 here and 5 here or vice versa. And after thinking about it just for a few minutes, I figured out that would be a 12x and a 5x. If you look through, I've got a 12x right there and a 5x there, and I could get 7 out of that if I had a positive 12 and a negative 5. So we've got a nice simple factor. Now, again, this is wanting me to find where things are strictly above 0. So I'm going to start by finding that where 0 itself occurs. And on a quick number line, I know that one of those values would happen at 5/3 and one would happen at -4. But I don't want 0. I want things that are strictly greater than 0. So I'm going to have to go ahead and put that open circle story here at each of those because I'm allowed to get close, but I'm not allowed to touch. Now, there's a couple of ways that we could play this. So I'm going to go with a very simple way. We have basically made this into a region of 3 values, 3 areas, where everything is true or false in each one of those 3 regions. So if we picked a number to the right of 5/3, and I'm just going to pick something convenient like 10. And if I plugged in 10, 30 minus 5 is 25. And if I pick 10 here, 10 plus 4 is 14. Now, the whole reason we factor is because we turned it into a multiplication story, a product. And I know that if both of these factors are positive, then their product will also be positive. And that's actually a good thing because I'm looking for a product that is in fact above 0, which makes it positive. So all of these values are true. Now, since one of them was true, they're always true. Now in here, we could try a simple number like 1 or -2, but 0 is really nice. And if I plugged in 0, I get 0 minus 5, which is clearly negative. 0 plus 4 is clearly positive. And I think everybody knows that the product of a negative and a positive is going to be a negative, but that's not something I want because this says I strictly want positive values. So I don't want to be in here. And then, of course, last but not least, if we come to this left side, anything that you plug in out here, like -10 or -100, this portion is going to be negative, and -100 plus 4 is -96. The product of two negatives is a positive. So it appears that this is the region that works. So we can either express it as x is less than -4 or x is greater than 5/3. That's inequality notation. Or we could write the interval notation. X is an element of all of those values from -infinity through -4. Right? I can have anything that I want in there, and not including -infinity, not including -4, because we can't reach that, or anything from 530 to infinity. This is actually the notation I prefer, but all 3 of these are legitimate. Now, this is technically a one-dimensional question because if you look back at the question, there's only one variable. And if I made a two-dimensional graph, like on an XY plane, that's technically two variables, but it is kind of helpful. Because if I were to think about what this graph looks like in a two-dimensional story, I've got these two roots, one at -4 and one at 5/3. This is a parabola because 3x squared with a positive leading coefficient needs to be an upward sloping parabola. So I know that it looks something like this. And so interpretively, although this is a one-dimensional story, it's being smashed down onto the plane, what we have is a situation where the graph is above the axis here and here, and you can see that actually lines up with this. So if I just thought about the fact that it was a smiling parabola, I would have known that it's up on the sides and down in the middle, and therefore I knew these were the ones that I wanted since I wanted positives. So you could either do the true or false thing, or you could just think about the general shape of the curve, and that could help. Now, for the second question, a little bit harder. I purposely made this one to not factor. Now you could try it. Again, when a problem appears to not be factorable, I usually try to push on it anyway. If nothing jumps out at me, I will go with the diamond problems that we've talked about, but I can't come up with two numbers that multiply to -10 and add 8, so I'm kind of stuck. So what I'm going to do first is I'm going to try to complete the square. Now, again, for my take, I love completing the square. I feel like it's just the fastest way for me. Now, we're supposed to take this term here in the middle, cut it in half, which is going to get me 2. Remember that. It's going to give me the number 2. And then I square it, but I need to add that to both sides. So I've added 4 to both sides. So I'm sitting at this story that x plus 2 quantity squared. And again, I'm going to pretend that it says equal. And we talked about that in class, how sometimes we can do that. X plus 2 quantity squared. And this is going to be 8 halves plus 5, which is going to be 13 halves. And we're going to take the square root of both sides. So x plus 2 is equal to plus or minus the square root of 13 halves. And so if I move that 2 across, we're going to have -2 plus or minus the square root of 13 halves. Now, this happened to some of you on your little group quiz, and this is something that I did. You're not supposed to have that 2 in the bottom. So we can simplify it a tiny little bit by multiplying the top by 2, which makes it root 26, and the bottom by 2, which makes it root 4, which again is 2. But what that generated, again, and I'm going to borrow this idea that I did from this video, is that we have -2 plus root 26 over 2. And back here we have -2 minus root 26 over 2. And clearly adding something is going to be to the right of subtracting something. So it's going to look like this. And notice when we go back to the original problem, I wanted less than or equal to. So equality was actually a good thing. And again, what I have is a positive parabola looking like this, right? If again, I was thinking about this as a two-dimensional graph with a y and an x, but I want that thing to be below 0, or in other words, where are those answers underneath the axis, which is clearly in this region right here. So again, we have our variety of ways that we could express that answer. But again, my favorite would be x is an element of -2 minus root 26 over 2, comma, excuse me. Yeah, this was supposed to be a -2 plus root 26 over 2. So again, kind of an ugly looking answer, but that's the answer that we got. And I wanted one of them to do that. Okay, moving on. All right, next question, kind of blended here together. Now, this one, again, definitely nonlinear. In fact, this is a quartic equation. It's a 4th degree. Man, that's going to be a little bit scary. But since it's a 4th degree, one of the things that you do if you ever go above a power of 2 is look for those greatest common factors. And what I notice is these both have an x squared in common. So I took an x squared out, which would leave x squared, since x squared times x squared is x to the 4th. Now, if I factored out that number, that's kind of what happened. If you distributed, you'd get that back. Now, what remains is a very simple factorable quadratic, kind of like the first one, but even easier. Because I think everybody in here knows that 10 could be made of the product of a 2 and a 5, which I could get this number very easily with a 5 and a -2. Now, like I said, I'm going to go ahead and make a number line out of this. Since I was able to factor it really nice and easy, I'm going to place those values where 0 happens, because remember, I like 0. And 0 happened at -5. 0 happened at +2, and 0 happened at 0, right? Okay, so we've got some of those values. And then again, if we try a number to the right of 2, like 6 or 10 or 100, that term is positive. 10 squared is positive. 10 minus 2 is also positive, and 10 plus 5 is positive. See, it's any number that I plug in, 10, 50, 100, each one of these three pieces is positive. So if we took the product of those three positives, I know I'm going to get a positive answer. And this is actually saying that's what I want. So all of these numbers will be true. They're going to be part of that region. Now, if we tried the number 1, 1 squared is positive, but 1 minus 2 is negative, and 1 plus 5. Again, I tried 1 because it's in the middle. So 1 squared is positive, 1 minus 2 is negative, and 1 plus 5 is positive. But the product of two positives and a negative is a negative. Well, that's not what I want. So we don't want to be in this region right here. Don't go there. Okay. Now, frequently, these values will alternate pluses and minuses as you go through, but it doesn't always happen. So let's try out here a number like, let's say, -3. So -3 squared is positive. -3 minus 2 is negative, and -3 plus 5 is also positive. Well, something weird happened. I got two positives and a negative again. And the product of two positives and a negative is a negative. I don't want negatives, so this is bad as well. That's kind of weird. But out here, if we go to the far left, like -10 squared is positive. If I plug in -10, I'd get a negative here, and -10 would yield a negative answer here. And the product of two negatives and a positive is a positive, which is good. So this is a strange problem because what I'm telling you is all of these are good answers. All of these are good answers, but not that only. This one value right here is a good one too, because it's not greater than 0, but it is equal to 0. So my solution would be x is an element of -infinity to -5, or from 2 to infinity, and then I'd say or x equals 0, because I have that extra little piece, but I can't really make much of an interval out of that because it's not an interval. It's a point where that's actually true. So that's pretty much all I can do on that problem. And the last one, the last portion, I was just going to be kind of quick and creative about it, is that I wanted to make this thing. So we had a problem a minute ago where if I wanted this to be a solution, I could imagine making a parabola that has these two roots. So keep in mind, a moment ago, I used the factor to find the roots, so I could just as well take the roots to go backwards and find the factors. So I just chose to draw an upward sloping parabola, and I want the region right in here to be true. Well, what I have then, if that is my true region, a value that is below 0, again, or equal to, because I had that, and these were the two values that I have. That's 3x plus 2 and 2x minus 5. So I generated a quadratic that matches this picture, and I just thought, oh, well, if I want it to be in the middle, I would make that the portion that's under. This is not the only way, though. And similarly over here, I want values below -1 and the values between 1/2 and 4, but I don't want anything out here. So just like I did before, and I got to think about this for a second, I'm going to go x plus 1. I'm going to go 2x minus 1, and I'm going to go x, let's say, minus 4. Those are the three factors that would go to those roots. Now, if you think about it, if I tried a number out here to the right, like 10, this would be positive, this would be positive, and this would be positive. But I didn't shade the product of positives, which is positive. I didn't shade positive. I shaded clearly negative. So I want the other side of that coin. If it had been these two, I would just flip that over and I'd be good. And I made it less than 0 because I was not inclusive of those numbers. And so that's just a way, again, not the only way, that's just a convenient way to do it, that I could check my answer, like pick a number like in here, like 2. 2 plus 1 is 3, which is positive. 2 times 2 is 4. 4 minus 1 is 3, which is still positive. But 2 minus 4 is negative, and the product of two positives and a negative is, in fact, under 0, which is what I wanted. Now, last question's kind of a trivial, silly one. I want to know if an answer, and it's some inequality that can't be true. And this is just very, very easy. I could say something like, I want to know when x squared plus 6, pretty simple idea. We know what x squared plus 6 is. It's a little problem like that, right? I want to know when is x squared plus 6 below 0? Well, it's never below 0. So if I tried to find out where am I getting those negative numbers, the answer is I can't. So this would be no solution. But in the same case, if I said where all real zeros, that would be like when x squared plus 6 is greater than 0. Because if you look at the graph, x squared plus 6 is always some positive value. If I square something and add 6, there's no way I can fail to just get a positive answer. So hopefully that is helpful, kind of reviewing over some of those P4 concepts. Again, non-linear inequalities, and I will see you guys back in class. Hopefully that was helpful. All right, have a good day, and